Hello everyone. Am I audible?
Yes, ma'am.
Okay, so this is your week 12 open sessions. So in the last session of week 11, you have studied about the discrete distribution. Okay, and in week 12, we have to study about the continuous distributions. So is my screen visible? My screen is visible, right?
Yes, ma'am.
Yes, ma'am.
Yeah, okay. So first of all, you should understand what is the difference between continuous and discrete random variable. So anyone, what is a continuous random variable and what is a discrete random variable? Okay, so discrete random variable is a variable which is countable. So which takes discrete or distinct values, okay, which we can count. But a continuous random variable is something which takes values in an interval and it can take any value in that specific interval. So that's why continuous variable is not countable, but it is measurable. Okay, and discrete variable is something which we can count. So it is countable. Okay, so here we have to study about the continuous random variable. So first of all, if you have x as a discrete variable, suppose, then you must have studied about the PMF, right? What is PMF? Anyone? Okay, what is the full form of PMF?
Probability mass function.
Yeah, it is probability mass function. And how we define it? So suppose we have a random variable x which is taking values, suppose x1, x2, up to xn. Okay, and we write the corresponding probabilities, right? So here we define the probabilities that capital X random variable is taking value x1 and then it is taking value x2, okay, and for xn it is taking value xn. Okay, so we write the value of the random variable and we write their corresponding probabilities. So this is how we define probability mass function.
I
Okay.
have a question here. So I'm a bit confused here. So, how do you differentiate between the discrete values that it takes and what would be the in a sense, are you calculating the probability for every single discrete variable that has to appear in my event?
Yeah, this is for discrete case.
Okay. Okay.
Okay, this is not for continuous. This is for discrete. Okay. So here in discrete case, whatever values x is taking, okay, we have to find the uh, probability for each possible outcome.
Okay.
Okay, so
Okay.
we can write in this form also, or we can write the PMF in the form of function of x also. Okay,
Okay. Mhm.
yeah. So this is for discrete random variable. So these things you have studied up to week 11. Now we have to see probability density function. So if x is a continuous random variable, okay, it is a continuous random variable, suppose, then we have a curve associated with every continuous random variable. That is called probability density function, PDF. Okay, PDF, which is probability density function. Okay, and in short, sometimes we denote it by fx. okay, by small fx. Okay, so this is small fx. So this is used to denote the PDF of a random variable, of a continuous random variable. Okay, so there are some properties for PDFs. Okay, for a function to be a valid probability density function, there are two conditions, or we can say two properties. So in PMF also, you must have studied the properties. So what were the conditions or properties for PMF, if you remember?
The sum of the all the this should be one. So
Hmm.
EMF should be one for any
Mhm.
solution. And yeah, I mean, the integral of minus infinity to infinity f of x dx should be equal to one. So area under that distributive curve should be
Yes. Yeah, and the other one, it should be non-negative,
yeah, it's not negative.
right?
Yes,
Yeah,
yeah, because it's computing the area.
yeah. So the first property is that the fx, that the function PDF, which we call as PDF, it should be greater than or equal to 0. Okay, which means it should be non-negative. And the second one is that the total area, okay, total area under the probability density curve of a continuous random variable, okay, it is always 1. And how we calculate it, how we can represent it mathematically? So we have to integrate this function, okay, which is a probability density function for a continuous random variable, okay, over the limits. So I can write, generally I can write it like minus infinity to plus infinity. So that should be equal to 1. Okay, so these are two properties of PMF. Sorry, PDF. Okay, and what is this area under the curve? So this function is the probability density function. You can, if you want to make a graph, then it is like a curve. It can be any curve, but generally I am making it like this. Okay, so suppose this is our x-axis and y-axis, and this is the curve, suppose. Okay, then this area, suppose this is point A and this is point B, then this entire region, okay, which is under this curve. Okay, so that area should be equal to 1, total area. Okay, and this function is what? Fx. Okay, so these are the two properties for PDF. Okay, now suppose there is one property. So you have, suppose, your PDF like this, and you are taking any points between these two. Okay, suppose these are A and these are B. Okay, these are anywhere in between the curve like this. So if you want to calculate the probability, okay, where we are saying that the random variable, continuous random variable x takes values, okay, between points A and B. Okay, we have to find the probability that our random variable x is falling between the points A and B. So these are the 2 points A and B, and we have to find this probability. So how I can write it? So may I write it like this? That x is between A to x, A to B,
Yes, ma'am.
right? And this probability is representing what? So this is nothing but the region or the area covered by this. So the points A and B, okay, this is somewhere between the curve, suppose. Okay, so these two lines of x equals to a and x equals to b and the curve. Okay, so this entire region, okay, so this area will be given by this property, this probability, sorry. Okay, so this, and how we can find it? By using
The
PTF.
integral.
Okay, yeah.
Yeah.
So it is
A
a
to B.
integral, yeah, integral of the function fx, which is a PTF, and the limits will be a to b. Okay, this is how we calculate this probability. And you can remember this thing, that if x is a discrete random variable, okay, if x is discrete random variable, so in that case we write the probability that a, okay, so in that case, this is, if you have studied this formula, this is what? CDF at point B minus CDF at point A, right? Or for simplifying, I can write it like this also. Okay. Now may I write that it is FB minus FA. Okay. Is it clear to you?
Yes, ma'am.
Okay. This is for discrete random variable. And for continuous random variable also, this rule follows, but you know that for continuous random variable, if I write that probability x is less than a, so that is same as the probability if I write probability x is less than or equal to a. Why? Because probability at point, at a single point, is zero for a continuous random variable, right? So we can write that the probability x is equals to a will be zero for continuous random variable, right? Okay, so for continuous random variable, these two probabilities are same. Okay, do you agree with this point? Okay, so we can write like this also, that probability for continuous random variable, that this is same as this, or we can write like this or this. Okay, so for continuous random variable, all these four probabilities are same. Okay, because probability at a point is zero. And why it is zero? We can prove this thing also. So if you have to find probability from point A to B, suppose, then how we find it? It is A to B fx dx, right? Okay. And if you have to find the probability at a single point A, suppose, then may I write like this? Okay. X is less than A or equal to A, which means less than A or greater than A, which means it is nothing but the probability at point A only. So if I use this formula and find this probability, it will be from A to A fx dx, right? And A to A fx dx, so it will be equal to 0. Yes or no?
Yes, ma'am.
Okay, because when you integrate this function, and you will have to put the same value. Okay, so it will be the integrated function of x, and then you will put the value a. So fa minus fa. So the both the values will be same. It will be cancelled out. It will become 0 ultimately. Okay. Is these things clear to everyone or any confusion? Any doubt?
No, ma'am.
Okay. So next thing we have to see is the cumulative distribution functions. Okay, and in short, we write it as CDF. So what do you understand by cumulative distribution function? Anyone? So CDF is a function which accumulates the probability up to a certain point. Okay. So for a continuous random variable, so in this week, we have to study everything about continuous random variable. Okay. So for a hello, am I audible?
Yes, ma'am.
Yeah, sorry, there was a network issue, so I got disconnected. Yeah. So if we have to find the CDF at point A, so how we can write it? So it is probability that X is less than or equal to A. So what it function does, it adds all the probabilities up to a certain point. Okay, so here that point is A. So how we can write it? Using the PDF.
Ma'am, we can take cases where the points lie between 0 to A. And so x less than 0, it would be 0. And from uh, x equal to A, not x equal to A, not x equal to A.
See,
For
here we
A,
are talking about continuous random variable and not discrete. Okay,
yeah,
so we cannot add the probabilities for distinct point. Okay. Also, so what we have to use, we use integration for continuous random variable always. Okay. So what we have to do, we have to add, like we have to integrate this function PDF. And what will be the range? So we have to integrate up to a point, like the point at which we have to find the CDF. So here that point is A. You can see X is less than or equal to A. Okay, suppose this is our X axis and this is the point A, and we have to find the probabilities. Okay, so below this point, we have to add all these things. So upper limit should be A only, right?
the lower
Yes,
limit should be minus infinity, right?
and lower limit will be minus infinity. Okay, and so here I am writing it as a general form. Okay, and if you are given a particular distribution, then we have to see the range according to the distribution it follows. So if in case you will see the different continuous distribution also, like uniform distribution, exponential distribution. So in that case, you will have to see what is the lower limit for that particular distribution. Okay, and we will use that limit. But in general, we write minus infinity. Okay, so this is the formula for cumulative distribution function. And since it is a continuous random variable, okay, here, so we can write it like this also. So these two are same. Okay. Is this clear to everyone? So next we have to see expectation and variance. Expectation and variance you must have studied for discrete variable also. Okay, just a small changes there and you will be calculating the expectation and variance for continuous variable. So how we define expectation of x? What is the formula for discrete case?
Ma'am,
Anyone?
is it n plus 1 over 2 for a uniform?
No, see, we don't have to write for a particular case. In general, if you have to find, then how will you find the expectation of x
Ma'am,
for
like,
any given
For
distribution?
discrete,
ma'am, for discrete or continuous? Continuous, right?
Yeah, we have to find for continuous here, but first of all, tell me for a discrete case, because that you have already studied.
summation of xi
Yes, ma'am, you
and
multiply it's sum
of
of
pxi equal to px equal to I.
Yes, okay. So we take the variable into the corresponding probabilities. Okay, so similarly, we can find here also. So x, okay, into we have to use PDF here, okay, because it is a continuous random variable, and we will integrate, okay, because it is a continuous, we will not use summation, we will use integration. Okay, so it is nothing but summation, integration of x into fx dx. Now we have to find the variance of x. So the formula for variance, what is the formula for variance if you have to find? It is the,
For discrete or continuous?
yeah, in general, what is the formula for variance? It is the expectation of x minus
X,
expectation of x
x
whole
whole
square, right? So this is the
Yes.
formula for variance of x. Now can you tell me how can we write it for continuous case?
Ma'am, it will be the integration of that function times f of x dot dx.
Yeah, so it will be x
X,
minus expectation of x, okay,
the whole square
whole
multiplied
square.
by f of x dot dx.
Yes, okay, so this is the formula for variance of x. So how you can remember it? So you have studied the expectation for a function of a random variable x, right?
Yes,
So
ma'am.
if I write, okay, so if you don't want to remember everything, you will remember this formula at least. Okay, that variance is expectation of x minus expectation of x whole square. If I write this function x minus expectation of x whole square as y, then what you have to find? You have to find the expectation of y. Okay, and that you can easily find. So this is defined by y into the distribution PDF. Suppose it is fy, then dy, right? In that case, so here also, so y is a function of x. So you can write fx here. Okay. So you just simply have to write the function. You can see x minus expectation of x whole square. This function into the PDF, and you just have to integrate the function. Right? So this is the formula for variance of x. Now we have to find, we have to study the continuous distribution. So the first distribution is uniform distribution. So what do you understand by uniform distribution? Whatever you have studied till now.
Ma'am,
So if you have, okay, tell.
No, ma'am, it's okay. Go ahead.
No,
For
you
a
can tell.
for a specific interval, the distribution will be uniform.
Distribution will be
Uniform.
okay. So in uniform, we say that if you have studied it for discrete case also, then you will see that for all the outcomes, for all the values taken by x, the probability will be same. Okay, suppose, okay, first I am talking about the uh, discrete case, and then I will make you understand it for the continuous case. So if x is a discrete variable, taking values x1, x2 up to xn. So it is taking n values. Then in that case, we will see that for each x1, x2 up to xn, the probability will be same, which will be 1 by n. Okay. So which means it is uniformly distributed. Now, if I talk about continuous case, so we say that for each interval, the probability density function will be same, which means they are equally likely. So how we define it? So it is represented by like this. X follows uniform distribution A comma B. Okay, and we can write the PDF. So it is a constant function. So here the range of the distribution is starting from A going up to B. So for A to B, PDF is a constant. Suppose it is K. This is for discrete case, don't get confused with it. Okay, and here it is for continuous. So the PDF will be constant. Now how we can find this constant value? So we can use the property, which is the property of PDF. Okay, so here it should be equal to 1. And what should be the range here?
A to B.
A to B, right? So the PDF over the range of the distribution should be equal to 1. Now we are saying that the PDF is a constant. So we can write that A to B fx, suppose we have written it as K, KTX should be equal to 1. Now if I integrate, so it will be K x, okay, from A to B it should be 1. So K B minus A is equals to 1. So that constant K is equals to 1 upon B minus A, right? Now we have found the value of that constant K. Now we can define our probability density function for uniform distribution. Okay, so it is given as 1 upon B minus A if the interval is from A to B. Okay, and this will be 0 otherwise. So in this interval A to B, the PDF will be 1 upon B minus A. Okay, and if you are trying to find out the PDF for any other point, okay, which is outside from this range, then it will be 0. Okay, so if I try to make the graph of it, so suppose this is A and this is B. So here we can see that it is a constant. So the curve will be a straight line. Okay. Because it is uniformly distribution, so it will not be curved like this. Okay, so here we have a constant value, so which can be represented by this line. So you can see that from A to B, it is same for every point. Okay. Any doubt?
No.
Okay. So this is uniform distribution when we have the range as A to B. Now we will see the standard uniform distribution. So in standard uniform distribution, x follows uniform 0, 1. Okay, so lower limit is taken as 0 and the upper limit is taken as 1. This is the only change. Okay, so now you can use these PDF function, you can see and you can find the PDF for standard uniform distribution as well. So can you tell me what will be the PDF here?
It's 1.
1. Okay. So the range is from 0 to 1. Okay. And the formula is 1 upon b minus a. So 1 upon 1 minus 0, which will be ultimately 1. Okay. And 0 otherwise. And if you want to check whether this standard uniform distribution is valid or not, if you want to check, so you can use the properties of PDF and you can check, you can verify it. So the first property is that PDF, that fx should be greater than or equal to 0 always, right? Which you can see that either it is 1 or 0. The first condition is verified, right? Second condition is what? That the integration fx dx should be equal to 1 over the range. Okay, so here you can see that from 0 to 1, fx dx should be equal to 1. Okay, so you can check this thing. You have to verify it. So it is 0 to 1 and fx is what? 1, right? So 1 into dx. So which will be? It will be x, okay, from 0 to 1. Then it will be 1 minus 0, which is 1. Now you can see that the second condition is also satisfied. So both the conditions are satisfied. Now you can see that standard uniform distribution is valid, right? If you want to make the graph of this one, standard uniform, it will be something like this. So range is from 0 going up to 1. So it will be a straight line like this. Okay. Is this all clear to everyone?
Yes, ma'am.
Next, we have to see the CDF for uniform distribution. We have to find the CDF. Okay. So if X is following uniform distribution A comma B. Okay, suppose this is the line. This is the range A and B. So first of all, tell me if X is less than A, then what should be the CDF in that case? Can you guess?
0. 0.
It should be 0. Okay. Why? Because the PDF is defined in the range A to B only, right? So the PDF will be 0 if X is taking value below A, right? So if PDF is 0, then you integrate it, it will be 0 only. Now, if I say that X is greater than or equal to B, in that case, what will be Fx? CDF?
0.
X minus A, B
0.
minus A.
0.
Uh,
Oh, sorry.
no, for X is greater than or equal to B. It should be 1.
1.
Okay, we will see this thing, how it is 1. Now we have the range A to B. So we have to find the CDF in the range A to B. Okay, so
X
first of
minus
all,
A.
we will calculate Fx in this range.
Ma'am,
Yeah,
here
one
it will be
Hmm.
x minus a over b minus a, like
Yeah, this is the formula that it is x minus a divided by b minus a. Okay. So we have to integrate the function 1 upon b minus a. So if I write it generally, what we have to do, we have to we can write it like this. Fx is, that x is taking value less than or equal to x, right?
Yes,
Okay.
ma'am.
So we can write. So now here we can divide it into two parts. So first will be like minus infinity to a, and then a to x. Okay. And x is any point between in this range, a to b. Okay. So here you can see, so it will be minus infinity to a fx dx and a to x fx dx, right? Now you can see that from minus infinity to a, what is the value for PDF?
0.
0. Okay. It is not defined below a, so it will be 0. Now from a to x. Okay. So from a to x, and the PDF is 1 upon b minus a, right? You just have to integrate this thing. So 1 upon b minus a is a constant, so I can write it outside the integration. Then it will become x, a to x, right? So that will become 1 upon b minus a. If you put the values, it will become x minus a. Okay, so ultimately the CDF at point x will be x minus a divided by b minus a. Okay, so this will be, you can see here. So from this range a to b, okay, it is including the point a. Below a it is 0, but from point a to b it will be x minus a divided by b minus a. Okay, now how it is 1 for x greater than or equal to b. So you can see that it is first of all, for x is equal to b. Okay, if you have to find the CDF at point b, then what we have to do? We have to integrate from a to b fx dx, right? In that case, from lower limit to the point at which we have to calculate the CDF, right?
Ma'am, it's 1.
Yeah, it should be 1, but how it is 1, that's what I am explaining here. So FB, how you will calculate this? If you have to find the CDF at point B, this is the
Ma'am,
formula, right?
will it be f of b minus f of a?
Okay, see. I'm explaining how f of x is 1 at point x is greater than or equal to b. Okay, so you can see that the distribution is defined in this range from a to b. Okay, you have to find the CDF at point b. So the formula will be probability that x is less than or equal to b, right? If I have to calculate, how you will calculate it? From lower limit to the point at which we have to calculate the CDF, which is b, right?
Yes,
Okay, so it will be b, and the lower limit is a. Now you can see that this is the property of PDF. We are defining, we are integrating the PDF over the entire range, right? From a to b, then it should be equal to 1 only. Okay, which means we are accumulating all these probabilities, right? That should be equal to 1 according to the property of PDF, right? Okay. And if you want to find the CDF at any point which is away from it, okay, which is suppose C, there is a point C which is greater than B. So you want to find the CDF at point C. Then how we can write it? So it is like x is less than or equal to C, right? Also, I can write that from lower limit to B, and then it is from B to C. Okay. Is this point clear how I have written this thing? Okay, if you want to calculate the probability or if you want to calculate the CDF, okay, I'm explaining the last term, this one, okay, how x is greater than equal to b, how the CDF is 1 at that point. So for x equals to b, I have explained, and for x is greater than b. So suppose greater than b, which means I am taking any point which is greater than b. Suppose it is c. So we have to find the probability x is less than or equal to c. In that case, I can write it like this.
Yes, ma'am.
Okay. So this is one we have calculated. Okay.
Yes.
And this we can write that from b to c fx dx. Okay. Now tell me what will be this value? The second part?
Ma'am, it will be 0.
Yeah, it will be 0 because we can know.
0 because it's not defined.
Yeah, it's not defined. It is 0 in that case. Okay. From A to B only, the PDF is 1 upon B minus A. Outside A to B, the PDF will be 0. Okay, so this will become 0. Now, the CDF function is clear to everyone for the uniform distribution?
Yes.
Okay. So here we have calculated it for uniform A comma B. If you have to find it for uniform, okay, so if X is following uniform distribution, standard uniform distribution, then what will be the CDF? Now you can directly use the above formula. Okay. So for X is less than A, which means 0 here. Okay. So for A, B, here it is 0 and 1. So X less than 0, it will be 0. Okay. X greater than or equal to 1, it will be 1, right? And from 0 to 1. Now tell me, according to this formula, what should be the value here? So A is 0 and B is 1.
1 only.
It will be X because X is
X.
also here. Okay.
Mm.
So in that case, it will become X.
Oh, in the second case, yes, it should be X.
Yeah. Okay, so it will be like this. Is this clear to everyone?
Yes.
Okay. So if you want to see the graph for CDF for uniform distribution, so you can see that for uniform A comma B, okay, fx is generally defined as x minus a divided by b minus a, right? This is a CDF function for uniform A comma B. I can write this function as x upon b minus a plus minus a upon b minus a. Or I can write it like this, 1 upon b minus a into x plus minus a divided by b minus a. Okay, so this is the function. Now, if you compare it, it is similar to m. Suppose this is y equals to mx plus c line, right? Now this function has become in this form, y equals to mx plus c. If you have studied this thing in mathematics.
Yes, ma'am.
Okay. And how you draw this line, y equals to mx plus c? It is something like this line.
Yes.
Okay. So suppose you have to draw the figure for uniform 2, 4. So in that case, the figure will be something like it is 2 and it is 4. So it will start from this and will go up to 1. So this is the suppose maximum point 1. Okay, at 4, it will be maximum, it will be 1. And if you want to draw it above 4, it will be a straight line
1.
because, yeah, it will be 1 only. Because for all the points which are greater than or equal to 4, it is 1. So it will be a straight line for the point 1. So this is how you can draw the graph for CDF for uniform distribution. Okay, because we know what is this line, y equals to mx plus c. Okay, similarly for uniform 0, 1 also you can find for standard uniform distribution. So here it is starting from 0 and the upper limit is 1. So it will be like this. Okay, suppose this is 1. So this is the maximum, and then it will be like this. Okay, is this clear to everyone?
Yes, ma'am.
Okay, next we have to see the expectation and variance for this distribution. So next is expectation. So X is following uniform distribution A comma B parameter. So expectation of X. Okay, so the formula is X into fx dx. Okay, and the range will be from A to B, right? Now just integrate this function, put the value. It is X, it is 1 upon B minus A, right, into dx. So 1 upon B minus A, I can write outside the integration, then it will become X square divided by 2. Limits will be A to B. Okay, so 1 upon B minus A, and that will be B square divided by 2 minus A square divided by 2. Okay, so we know that B is B square minus A square. I can write it B minus A and B plus A, right? Okay, this is the formula for B square minus A square. Then B minus A will be cancelled out, right? So we are left with A plus B divided by 2. So this is the expectation for uniform distribution with parameter A comma B. Okay, is this clear to everyone?
Yes, ma'am.
Okay, and it's better if you remember these formulas. So in that case, it will be easy for you to solve the questions in the exam. Okay, so you can remember these formulas for expectation and variance for the standard distribution, like uniform, exponential, normal. Okay, next we have to calculate the variance of x. So variance of x is equal to expectation of x square minus expectation of x whole square, right? This is the formula for variance. So expectation x we have already calculated. We need to calculate expectation of x square. Okay, what is the formula for it?
Ma'am,
How
it's
will we calculate?
the
X square
integration.
fx dx from A to B.
Yeah, x square fx dx, and the range is same A to B. Okay, so now again, so A to B, x square 1 upon B minus A. So we can write outside, it will become x cube divided by 3 A to B. Okay, so it will be B cube minus A cube divided by 3, right? Now you can open the formula for B cube minus A cube. It will be B minus A, B square plus A square plus AB, right? Divided by 3. Again, B minus A will be cancelled out. So expectation of x square will be B square plus A square plus AB divided by 3. Okay, now just put the value and you can find the variance of x. So expectation of x square is what? A square plus B square plus AB divided by 3 minus expectation of x whole square, which is A plus B divided by 2 whole square. You can solve these functions, these values. Okay, so when you solve it, after solving, the formula is B minus A whole square divided by 12. You can remember this formula. Okay, after solving, you will get this value. Okay, is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yeah. Next, we have to study the exponential distribution. So as we have seen that for each distribution, what things we have to remember? We have to remember the PDFs, right? What is the PDF function and what is the range? Okay, which means what values X is taking in that particular distribution. So here we can write that X is following exponential distribution EXP with parameter lambda. Okay, so in uniform distribution, two parameters were there, A and B. Here we have parameter lambda. And the PDF is defined as lambda e to the power minus lambda x. Okay, and here x takes values greater than 0. Okay, so it is basically defined for non-negative values. Okay, and it will be 0 otherwise. Now I am explaining in brief that where generally the exponential distribution is used. So, so basically the exponential distribution is used in queuing theory. So what is queuing theory is, so in queuing theory, we study about the service time and inter-arrival time, these things. Now, what is inter-arrival time and service time? So if you see that in a queuing system where we have like we have a shop or we have a bank or we have a hospital, okay, where number of people are coming in a system. Okay, suppose there is a shop which is a system and queuing which means a line of people. So which suppose number of people are coming to a shop. Okay, so suppose customer 1 comes at 10 o'clock and customer 2, second customer comes at 10:30 o'clock. Okay, so you can see there is a gap of half an hour, 30 minutes gap is there. So that gap between the arrival of two different customers is called the inter-arrival time. Okay, so that generally follows exponential distribution. Also service time. So suppose you are going to a salon and you are getting a service. Suppose you are taking a haircut. So that approximately takes, suppose, 20 minutes. So that 20 minutes is the service time. Okay. So these are the service time and inter-arrival time. So you will see that these service time and inter-arrival times follows exponential distribution. Okay, these are modeled as exponential distribution. So when you solve the questions in activity practice assignment, you will see these type of questions there. Now again, same things. We have to find the CDF, we have to find expectation, we have to find variance for exponential distribution. Okay, so first of all, CDF. So X is following exponential distribution with parameter lambda. Okay, so CDF at point A we have to find. This is nothing but the probability X is less than or equal to A, right? Now tell me what should be the range. Okay, first of all, I am writing it in general. So minus infinity to the upper point, which is A, right? Fx dx. Now tell me how should I break it according to the range.
You can go for minus infinity to 0, 0 to 8, right?
Yes. So it will be minus infinity to 0. Okay, and then from 0 to the upper point, which is A. Okay. Now you can see that from minus infinity to 0, the PDF is not defined. Okay, it is 0. So this function, this integral will be 0. Okay, now here we have to integrate 0 to A. 0 to A, and the function is lambda e to the power minus lambda into x dx. Okay, so lambda is a constant which will come out of the integration. Now e to the power minus lambda x, so it will be like this. 0 to A, right? Lambda will be cancelled out and minus sign will be outside here. So it will be e to the power minus lambda A minus e to the power minus 0, right? What is the value for e to the power 0?
1.
1. Okay. So now you can see that the CDF function at point A, it will become 1 minus e to the power minus lambda e. Okay, any confusion? Is this clear?
Yes, ma'am.
Okay, so this is the uh, formula for CDF. You can remember this one also, or you can solve it. But it's better if you remember, it will save your time in solving the questions in the exam. Next is we have to find the expectation and variance. So by using the same formulas, you can find the expectation and variance for exponential distribution as well. Here I am writing the direct formula for it, okay, which is very easy to remember. So expectation x is defined as 1 upon lambda. Okay, you can see that lambda is the parameter. So 1 upon lambda is the expectation and variance is 1 upon lambda square. Okay, so whenever x is following exponential distribution with parameter lambda, you just have to take 1 by lambda. Okay, and the variance will be 1 upon the parameter square. Okay, if you want to solve, if you want to derive it, you can use the same formulas and you will get this value. Okay, now let's see a question based on the exponential distribution. So suppose the length of a phone call in minute, okay, is an exponential random variable with parameter zero point 0.1. Okay, so parameter is what? Lambda. So lambda is given as 0.1. Okay, if someone arrives immediately ahead of you at public telephone booth, okay, then you have to find the probabilities. So find the probability. You will have to wait. Okay, so the first part is that you will have to wait more than 10 minutes. Okay, and the second part is that you will have to wait between 10 to 20 minutes. Okay, so this is the question. Now read the question first carefully and then try to solve it. So the question is, suppose the length of phone call is in minute is an exponential random variable, okay, with parameter lambda equals to 0.1. So we can write that suppose the random variable is x, which is following exponential distribution with parameter lambda is equal to 0.1. Okay. Now, if someone arrives immediately ahead of you at public telephone booth, then you have to find that the probability you will have to wait for more than 10 minutes. So if I write in mathematical terms what it is, we have to find the probability that x is greater than 10, right? Do you agree with it?
Yes, ma'am.
Okay, so we have to find x is greater than 10. May I write it like this? 1 minus probability x is less than or equal to 10.
Yes, ma'am.
Okay. Now tell me what it is. Probability x is less than or equal to 10.
Ma'am, here we use the CDF formula.
Yeah.
So,
So it is CDF at point 10,
yes,
right?
ma'am.
So now we can directly use the formula. If you don't remember the formula, you will have to calculate this probability by integrating the PDF, right? As we do usually. Otherwise, if you remember the formula, it's good. Then you can directly use it. Okay, so if you have to find the CDF at a point A, then the formula is 1 minus e to the power minus lambda into A. Okay, so here we have to find the CDF at point 10, right? So it is 1 minus e to the power minus lambda into A, which is 10 here. Is this clear to everyone?
Yes, ma'am.
Okay, now you can see 1 will be cancelled out and this minus minus will become plus. So it will be e minus lambda into 10. So what is the value for lambda? 0.1.
Yes.
Okay, so 0.1 into 10. So this will become e to the power minus 1. Now by using the calculator, you can find the value of e to the power minus 1. It is 0.3678.
Yes,
Is
ma'am.
this clear? Okay. Now in the next part, what we have to find? We have to find that we have to wait for between 10 to 20 minutes, which means we can write that the value of x is lying between 10 to 20 minutes, between 10 to 20.
Ma'am, just a quick question. This, if you have done a simple integration for the first one, say this would be just 10 to infinity fx dx. So that would have fetched the same result, right?
Yes, if you directly solve this integral, okay,
Yeah.
then it will be
Yeah.
10 to infinity.
Yeah,
Yeah.
yeah.
Okay, so here, by using the property which we have seen earlier, we can write it like this, that probability x is less than or equal to 20, okay, minus probability x is less than or equal to 10. So since it is a continuous variable, we can write it less than 20 also or less than equal to 20 also. Okay, it will not affect. Okay. Now again you can see this is what? Again this is CDF. Right? You have to find between entities here. Is this clear to everyone?
Yes, ma'am. Ma'am, so this property applies to both continuous and discrete random variables, right?
Yeah, we can, this is for both, but you should remember that if I'm writing x is less than or equal to x and x is less than x. So for continuous case, these two things are same. But for discrete, if we are using a discrete variable, in that case, these two things are different.
Oh, ma'am, I meant the like probability of x being less than 20 minus probability.
Yeah, that you can use for both.
Okay, thank you.
So here again, we will use the CDF, which is 1 minus e to the power minus lambda e. So minus lambda into 20. Okay. Then minus 1 minus e to the power minus lambda into 10. Okay. Lambda is 0.1. So 1 minus 0.1 into 20 minus 1 plus e to the power minus 0.1 into 10. So 1 will be cancelled out. It will become e to the power minus 1 minus e to the power minus 2. right? Okay, now just put the values. So this was 0.3678. And what will be the value for e to the power minus 2? It is coming out to be 0.1353. And when you subtract it, it will become okay. Is this clear to everyone?
Yes.
Anyone who has any doubt? Okay, then the next distribution is normal distribution.
And what if P of X is greater than 20?
1 minute. Yes, you are asking for X is greater than 20.
Yes.
So if you have to find probability X is greater than 20, this one, right?
Yes, ma'am. Can we write it as 1 minus P X less than 20? And we have value for X
Yes.
less than 20.
In the first part, we have done this thing only. You can see if X is greater than 10, then we have written it like this.
Got
Okay, you
it.
can, yeah. Or you can directly use the integration function. You just have to see the range. You can do in that way also if you don't remember the formula. Okay. Okay, now next is normal distribution. So again, for normal distribution, we have to see two things. It's PDF, okay, and the range. And you should remember the parameters also. Okay. So in uniform, the parameters were A, comma B, two parameters. Okay. In exponential distribution, there were only one parameter, which was lambda. Okay. Now we will see for normal distribution. So we write it like this: X follows normal distribution. Okay. With parameter mu, comma, sigma square, where mu is nothing but the mean and sigma square is variance. Okay. So these are the two parameters. And the function, the PDF function is like this. It is 1 upon sigma under root 2 pi e to the power minus 1 by 2 x minus mu divided by sigma whole square. Okay. And the values taken by x is from minus infinity to plus infinity. Okay. So basically x is defined for all kind of values. Okay. It can be negative. It can be positive as well. Okay. But for exponential distribution, x was positive only. Okay. You can see x was greater than 0. If you remember this. Okay. So exponential distribution is defined for positive values of x. But normal distribution, x can take positive and negative values, both. Okay, now there is something to remember for it. So the normal distribution, okay, so it is a bell-shaped curve. So there are some property of it. First one is that it is a bell-shaped curve. So the normal probability density function, the normal PDF. Okay. So it is a bell-shaped curve. Okay. And it is symmetric about the mean value. Mean. So if I make the graph of it, okay, so this is x-axis, and it is something like this, bell shape. Okay, and symmetric about mean, which means, so this is the x equals to mu line. Okay, this is mu. Okay, so the first property is it is a bell shape. So you can see clearly that it is a bell-shaped curve. Symmetric about me, which means that this is the x equals to mu line. So now symmetric means we can say that this area will be equal to this area. Okay, so they both are symmetric at this side and at this side, both sides. Okay, is this clear to you?
Yes, ma'am.
So we basically it covers the 50% of the entire region, and this also covers the 50% of the entire region. And one thing that these two lines, okay, these lines never touches the x-axis. Okay, these are asymptotically parallel to the x-axis. If you have studied asymptotes in the mathematics, so they are parallel to x-axis, but they never cross each other or they never meet. Okay, you cannot draw the graph like this. Okay, it should be always like this. It should not touch the x-axis. Okay, this is wrong. This one is correct. Okay, these becomes parallel if you go beyond, but they never touch each other. Okay, now if I find the PDF at x equals to mu, okay, this is the PDF. If I put the value x is equals to mu, then this will be mu minus mu, right? So this will become 0. E to the power 0 is 1, right? In that case, the the PDF will be 1 upon sigma under root 2 pi, right? And if I put sigma equals to 1 in this form, then the CDF will be 1 upon under root 2 pi. Okay, which means you can see that if the mean is mu and the variance is fixed, sigma is fixed, standard deviation. In that case, PDF becomes like this. Okay, now by symmetricity, we can write this property as that the probability that x is less than mu, okay, it is equal to what? Probability x is greater than mu. And it should be equal to what value? Also, we know that it is a continuous distribution. So we can write x is less than or equal to mu, or probability x is greater than or equal to mu. Right? Do you agree with this point?
Yes, ma'am.
Now you can tell me what should be the value of it. Okay, so this is less than mu and this is greater than mu. And these two regions are symmetric to each other. So can you guess the value of this probability?
Ma'am, is it 0.5?
Yeah, is it 0.5 or we can write 1 by 2. Okay, so this is the half region, 50%. This is the half region, right? Okay, that's why we call it as that it is symmetric about the mean. Okay, this is the mean line. This is mu. Okay, now do you understand these properties? That it is a bell-shaped curve and it is symmetric about the mean. Okay, now we will study about the approximation rule. So in approximation rule, you have to remember few things. Okay, again, this is our x-axis. Okay, and I'm making a bell-shaped curve. Okay, this is our x is equals to mu line. Okay, this is what? Mu. Now you can see that x is following normal mu comma sigma square. And what do you understand by sigma square? Sigma square is variance. And what does variance tells you?
That how much it deviates from the mean.
Yes. So variance tells you how the other values deviates from mean, or it is telling you about the spreadness of the data set, right? So this is the mean. If I go towards one standard deviation away from this value, so suppose this distance is sigma, okay, which is one standard deviation away from the mean, then this point will be mu plus sigma, right? Yes, no? Okay, suppose this distance is sigma, and sigma is what? Standard deviation. So I am taking a distance of one standard deviation from mean. So this point is mu, and you are going this distance away from it, so it will become mu plus sigma. Again, this is sigma, so it will become mu plus 2 sigma. And then this point will become mu plus 3 sigma. Do you agree with it or not? Say something, yes, no?
Could you please repeat it? I'm sorry.
Yes. So I'm saying that this is the line, okay, which is x equals to mu line. It is x equals to mu, okay? Now I'm saying that I am going one standard deviation away from this value. So suppose this distance, okay, this distance is equals to sigma. Then what will be the value for this point? It will be mu plus sigma, right?
Yes.
Yes.
Okay, so I am going one standard deviation away from the mean. Okay, it is mean, and I'm going one standard deviation away from it. Okay, this is the distance. So this point will be one mu plus sigma. Now again, this is the sigma distance. Okay, so this point will become mu plus 2 sigma. Okay, and this again, this is the sigma distance. This point will become mu plus 3 sigma. So we can say that this point is one standard deviation away from me, and this is 2 standard deviation away from me, and this is 3 standard deviation away from me. Okay, similarly we can go for the left side also. Okay, so this will be mu minus sigma, okay, and this will be mu minus 2 sigma, and this will be mu minus 3 sigma, right?
Yeah.
Okay, now we have to see a few things here. So this is one standard deviation away from mean in both the direction. Okay, this is one thing, one point. Then 2 standard deviation away from me, which means this thing. Then it is 3 standard deviation. So now there is a rule which says that within one standard deviation away from mean, okay, in both the direction, okay, which means this area, okay, this entire region, this entire yellow region, which means one standard deviation away from mean, okay, within this line. So this entire region is 68% of the entire, approximately. Okay. So this region is 68%. Okay, is this clear?
So you mean to say this particular block, this area under the curve, this thing is occupying 60% of the whole space.
Yes.
And
Okay, so
again, when I'm
Hmm.
talking about the left and right, I mean, I'm talking from my left and right. So that will mean that again, these the left and right will be of the equal portions, 16% and 16%.
Yeah. So this portion will be half of 68%. Okay. And this will be half of 68%. Okay. Because these two areas are symmetric to each other.
Okay, so that will be 34, 34, but we are exceeding
Yes.
100%, am I right? Oh, okay, sorry, 34 plus 34.
Yeah. Okay. So this is 68%, this yellow region. Okay. Which means if you are going one standard deviation away from mean. Okay. So this yellow block will be 68% of the entire region. Similarly, if we go two standard deviation away from mean, which means this. Okay. I cannot color it. Otherwise it will be confusing. Okay. So this red, like up to this line, you can see that this line and this area. Okay. So this will be 95% of the entire region. Okay, just imagine this entire region, this yellow one and this one, and this one. I'm not coloring it, otherwise it can be confusing for you. Okay, so if you are going two standard deviation away from mean in both the direction, then in that case, it will be covering 95% of the entire region. Similarly, if you go three standard deviation away from it, then it covers 99.7% of the entire region. Okay, so this is the approximation rule. And these are the approximate probabilities, not exact. Okay. Now, similarly,
Sorry to interfere.
yes.
So in this case, there is no point that it will be 100% coverage, or will it be there?
No, 100% we don't define because
Okay.
see, we in normal distribution we assume that most of the points lies within three standard deviation away. Okay, so if you go
Okay.
away from mu plus 3 sigma, like beyond this line, okay, and here this line, so there can be some points. Okay, that's why we don't say that it covers 100% because there can be some points, but these are negligible. So we assume this thing that within three standard deviation away from the mean, approximately 99.7% of the data points lies.
Okay. Okay. Thank
Okay,
you.
so approximately we take the probability of data point lying outside mu minus 3 sigma and outside mu plus 3 sigma. That will be 0 approximately.
Okay.
Okay, now by using the symmetricity of the normal distribution, we can find these reasons also. We can find this reason. So you can see, okay, so first of all, I will write these things. So we can see. So if a data point, okay, so mu minus sigma and mu plus sigma. So this will cover 0.68. Okay, so a random variable will fall in this region. The probability of this thing is approximately 0.68. I can write a normal random variable, okay, with mean mu and standard deviation sigma will lie in this region, will lie in this with probability, approximate probability, okay, approx probability 0.68. Okay, similarly, if I write for mu minus 2 sigma to mu plus 2 sigma, okay, in that case, the approximate probability is 0.95. Okay, similarly, for 3 standard deviation, so mu minus 3 sigma to mu plus 3 sigma, okay, so that will be 0.997. Okay, do you agree with these points? Then I will move forward.
Yes.
Okay,
Yes.
now if you have to find this reason only, okay, the half of the yellow reason to the left side, then it should be 68 divided by 2%.
Yes.
Okay, which means I can write,
30%.
yeah, so mu minus sigma comma mu in this region. Okay, just try to see this area in the figure, mu minus sigma to
Ah.
mu.
Yes.
Okay, so this should be 0.68
34.
divided by 2. Okay, yeah.
Yeah,
So
0.34.
0.68 divided by 2, which is 0.34. Okay, so now I can write that this is 0.34, and this will be also because this is symmetric to each other. Okay,
0.34.
now we have to find this reason. Okay, so we can see that within 2 standard deviation, it contains 95% of the entire, right?
Yeah.
So first of all, within mu minus 2 sigma 2, mu minus 2 sigma comma mu. So this should be half of 95%, right? So mu minus 2 sigma, which means here to here, up to mu. So this should be half of 95%, okay? Which means 0.95 divided by 2, which will be 0.4.
47. 0.47.
Okay. Now similarly for mu minus 3 sigma to mu. So this should be equal to what? 0.997 divided by 2, right?
45. 0.45.
4999.
49. Sorry. 49.
Okay. Now, if you have to find this reason only, then how we can find it? We can divide this entire reason and minus this. Then we will be left with this reason only.
Yes.
Okay, now you can see this entire is what? Mu minus 2 sigma to mu, which is 0.475. Right? So this entire is 0.475. Okay. And this is what? This is only 0.34. Now just subtract it and tell me what will be the value.
That will be 0.13. approximately.
Yeah, so it will be 0.135, right?
Precisely.
Okay. Now we have to find this much reason only. Okay. Then how we can find that? We can take this entire reason and we will divide subtract this reason, right? So this entire is what? Half of 99.7%. Okay, so mu minus 3 sigma 2, mu is what? 0.499. So this entire is 0.499. Now you can add these two, 0.135, 0.34, or you can directly subtract this value, 0.475. Okay, this is what? 0.475. Okay. So this will be 0.024. Right?
Yeah. Yeah. Yes.
Okay. Now by using the symmetricity, you can see that this will be also 0.135, this much only,
Okay.
and this will be 0.024. Okay, now is this clear to everyone?
Yeah. So invariably of the size of the curve, this percentage is going to remain the same, right? Whatever may be the size of the same.
Sorry, can you please repeat?
Invariably the size of the curve that you have drawn here, even if you draw a bigger curve, it will be the same proportion that will be maintained.
Yeah, proportion will be same.
Okay. Thank you. I'm sorry about the background noise. I mean, actually in the hospital, so I'm sorry for that.
Yeah, it's okay, no issue. Okay, now if you understand this approximation, then we can move on to the questions. Anyone has any doubt? Okay, then let's solve some questions. So suppose in the question we are given that a normal distribution and a normal random variable x, which is following normal with mean 69 and 6.5 square is the variance. And we have to find the probability that x is less than 82. Okay, this is something we have to find. Okay, now we will use the approximation rule and we can find this probability. So if I try to draw the graph of it, it will be something like this.
I'm sorry, what is the question?
Yeah, I have written it in the short. So we are given a random variable, normal random variable x, which is following with mean mu and standard deviation 6.5, or you can say variance 6.5 is square. And we have to approximate this probability that x is less than 82.
Okay.
Okay, so we have to find this probability. We can make use of the approximation rule. Okay, so first of all, I'm drawing the figure of it. Okay, so this is 69, right? Mu is equals to 69 and sigma is equals to what? 6.5. So if I go towards one standard deviation away, which means 69 plus 6.5. So it will become 75.5.
Yes.
Okay, this is mu plus sigma, one standard deviation away. If I go two standard deviation away, then it will become so mu plus 2 sigma, which means 69 plus 2 into 6.5. So then it will become 82,
82.
right? What we have to find here, we have to find x is less than 82. So we have to find this region. Okay, we have to find this entire region below 82 point. So what exactly we have to find here? So we can write for this particular question that x is less than 82, which means we have to find probability that x is less than mu plus 2 sigma, right? So there can be different ways to solve this question. So what we can do, we can subtract this entire region. Sorry, we can subtract this red region from the entire. Okay, entire we take it as 1. Okay, so from the entire 1, we can subtract this red region. Then we will be left with probability x is less than 82, right? And we know that above 2 mu plus 2 sigma is what? So this is mu plus 2 sigma. So if you go above it, it is taking 0.024 of the region.
Yeah.
Approximately. Okay. So 1 minus 0.024. Okay, then it will give you the probability of
0.0
x is
something.
less than 82.
0.0 something.
Okay, like this. Or what we can do, you can see it in the different way also. What we can do, we can add this. So you can see that to this point, it will be 50% below it, right?
Yeah.
So, or the second method is, so the half of it is 0.5. Okay, then we have to add this region, this green one. Then further in the green one also you can divide into 2, or you can use that 90, half of 95%. Okay, so there can be multiple ways to see this figure.
Can we just integrate this function from minus infinity to 82 and get it?
That you can do, but you can see the function of normal distribution, the PDF is very hard. So if you go for integration, you will not be able to do it very easily. Okay, so this is not very easy to integrate. We have to let something that x minus mu divided by sigma as suppose t, then you will integrate. It will be very lengthy. Okay, that's why we have so many things, so many information on normal distribution. It is very useful in statistics. Okay, so it's better if you use this approximation rule rather than integrating the function. Okay, so you can see in this way also that it is half of 0.995. Okay. Yes or no? Do you agree with this? So this is what? Mu plus 2 sigma, right? This is mu plus 2 sigma. So we just adding half of it. Okay, so mu plus 2 sigma contains 95% of the entire region. So this will become 0.95 divided by 2. So 0.5 plus 0.475. Again, it will be 0.975. Or there can be another way also. You can write it like this. Okay, so if you know this one, that you can add this region. Okay, this one and this one and this one. Okay, so this is 50%, 0.5 we have written. Now this is mu plus sigma, and then this one. If you see this figure, this is 0.34, and then this is 0.135. Do you understand this thing or not? Okay, so this is 0.5 first, then 0.34, and then 0.135. Yes, no? Are you getting my point? So this will also be 0.975. Just respond to me. Are you understanding these things or not?
I'm sorry, I missed the track here and got disturbed. In the second part that you are talking about, the R, you are giving the break here. Could you please come back to?
Yeah, second part or second this one or this one?
The second and third, because I missed the track here. I'm sorry.
Okay. So first one is clear. In the first part we have done from entire, we just have subtracted this red region, this one.
Yes.
Okay. This is how we have done. In the second part, how we have done, we have taken this 50% region, okay, below 69. This is 50%, okay.
Yes.
Then, you know, this is what? This is mu plus sigma, and this is mu plus 2 sigma.
Yeah.
Okay, so we can write that within mu plus 2 sigma, it contains 95%. So on the right hand side only, it will be half of it. We are taking at one side only.
Okay. Yeah.
Okay, so half of 95% and this 50%. Or we can see like this part and this part, right?
Yeah.
So like this 0.34 plus 0.135 proportion of area. Okay. So it depends on you how you want to solve it. So there can be multiple ways to solve a single question. Okay, so if you remember the approximation rule, you can find it in any way.
You mentioned that 82, I mean, right, the number that we don't have. So, but we are talking only about the right hand side, which is plus thing, mu plus sigma and 2 sigma, 3 sigma. But we didn't go to 3 sigma, whereas it is 82 is crossing. So we don't here we don't have to think about the negative part. That only the positive is fine.
You're asking about below it?
Yeah, this one. So
Yeah,
we don't
so
have
we
to
have, no, we are considering it. We have already taken it as 50%.
Okay.
Okay, so that's why I have written 0.5 and 0.5.
Oh, yeah.
Okay, and then we have added the left region.
Okay. So here the entire block is considered as 50% and we are going for it.
Yeah, then we are, whatever region is left to add, we just have taken that only. Okay, that's why I'm saying that it depends on
I'm
you
sorry
how
about
you
the
are
terms.
looking. Yeah, it can be confusing,
Yeah.
but just look at the figure and try to solve it by your own. You will understand it.
Okay. Thank you.
Okay, only three things you have to remember. You don't have to mug up all these things. You just remember that within one standard deviation, it contains 60%. Within two standard deviation, it contains 95%. And within three standard deviation, it contains 99.7. Else you can calculate by your own. If you understand the figure, it is like the property of symmetricity. Okay.
Okay,
Is
because
this clear?
I joined
Yes.
the session only at 5 o'clock almost. I hope I will go through the video for the first thing. So I think that will be the previous 1 hour is going to, it's a similar discussion or is something entirely different?
Yeah, so earlier we were discussing the continuous distribution only. It was uniform and exponential distribution, their expectation, variance, and series of these things.
Okay. I will watch in the YouTube.
Okay. Okay, one more question we can see here. So suppose we are given that x is following normal mu comma 3. Okay, and we are given that x is greater than or equal to 60. Okay, and this is 3 square basically. So this probability is given as 0.975. Now we have to find the value of mu. This is the question. Okay, so in the question we are given that x is following with mean mu, standard deviation is 3, and this probability is given to us. We have to find the value of mu here. Okay, now you can see if you look at this number 97.5, this is what? So this is a pole. This is mu. Okay, this is suppose mu plus 2 sigma. Sorry, this will be mu minus 2 sigma. And this will be mu plus 2 sigma, suppose. Okay, this is 2 sigma. So again, this is what is given. If you look at it properly, it is nothing but x is greater than mu minus 2 sigma. This given is given. Okay, and how you can see it, that this entire is 0.5. Okay, and if you break it down, so this is 0.34, right? And this is 0.135, right? Up to this point. So now you can see that 0.5 plus 0.34 plus 0.135. If you add these numbers, you will get 0.975. So ultimately, it is given that the reason above mu minus 2 sigma is 0.975. Now you can compare these two, that mu minus 2 sigma is given as 16. Okay. So from here you can find it value. So 2 into sigma is 3. Okay, this is 16. So mu will be 16 plus 6. Okay. So mu will be equal to 22. Is this clear?
Yeah.
Okay, so by looking at the question and drawing the figure, you can conclude whatever is given to us. Okay, just read these things carefully and try to grab the information given in the question, and then you can solve it. Is this clear?
Yeah.
Okay, so the next thing is the standard normal distribution. Okay, so next we have to do standard normal distribution. So in a standard normal distribution, what we do? So suppose x, so standard normal distribution, the variable is represented by z. And what we have to do? Suppose x is a variable. Okay, x is following normal mu comma sigma square only. And if we subtract the mean and divide by the standard deviation, then this variable becomes a standard normal variable, which means the mean will be 0 and the standard deviation will be 1. Okay, so if any distribution, any random variable, sorry, is following normal distribution with mean 0 and variance 1, then it is a standard normal distribution. So we can write that Z is a standard normal variable. Okay, is this clear? Just a
Yes.
small transformation we have to do, and you will get the standard normal variable. There are few properties of it. So the first property is that probability Z less than minus X. Okay, so this is equal to what? So if I draw it, then suppose this is suppose 0 because it is a standard normal distribution. Okay, so the mean will be 0. So suppose this is minus X and this is plus X. So Z is less than X, which means this reason. By symmetricity, I can write that this reason is same as this one, which means probability Z is greater than X, right? Yes, no?
Yes, because they are symmetric, right?
Yeah, okay. And we can write this thing 1 minus probability Z is less than X, the complement of it. So probability Z is less than X is also equals to 1 minus probability Z is less than X. Okay, you can verify these things by the figure also. Okay, which means what we are doing from the entire reason, we are subtracting this reason. Okay, which means you will be left with this one, which is same as this one. Okay, just whatever is written here, just try to see those things in the figure and you will understand it. I hope this will be clear to everyone. Now the next point is that probability. This is very simple that you know already. So this is nothing but like this. Z is less than B minus probability. Z is less than B. So that we have already seen. Nothing new here. Third one, you have to read carefully. The third property says that mod Z of mod Z is greater than A. Okay. So this is equal to 2 times 1 minus probability Z less than A. Okay, now we will prove this thing. So suppose this is the figure. Okay, this is mean, which is 0 here. And suppose this is a point minus A and this is a point plus A. Okay, now mod Z. So if you have mod Z, greater than A. Okay, so the first part will be if we take positive value, okay, then it will be Z greater than A. Okay, or second one could be if we take negative Z, right? Okay, because there is a mod. So we can take positive value and negative value as well. So we can write, so here we can write that Z is less than minus A. Correct or not?
Yes, sir.
Okay. So now here I can write it is that probability Z greater than A plus probability Z less than minus A. Right? So this is probability Z less than Z greater than A plus probability Z now here in the first part you can see that probability Z minus X is equal to probability Z greater X. Z less than minus X is equal to Z greater than X. So here I can write that it is nothing but Z greater than A. Right?
Also write it like P of Z less than A minus P of Z less than minus A, right? We can also write that.
In that way.
Yeah, exactly.
Yeah, we can write in that way also.
Because Z actually lies between minus A and A.
Yes. So here it will become 2 times probability Z is greater than A. Okay. Now it can be written as the probability Z is greater than A. We can write it 1 minus probability Z less than A. Right? Now you can see this is same. We have proved it. Okay. So if you want to write this formula, okay, this one you can write in that form also. You will get some another form of it. Okay. Now is this clear? Yes, no?
Yeah.
Yeah, so these were the things in your week 12. If you want to ask anything, you can ask.
I mean, I have, because like we already got that mail emphasizing on the portion of the interim, which is to do with from 9 to 12, is that what's being emphasized for the what do you call interim syllabus for STAT. So is it that, like, can I consider that if I focus more on 9 to 12, that is sufficient?
See, in end-term exam, like we can say that 60% of the questions will come from week 9 to 12. Okay, but 40% questions will be there from week 1 to 8 also.
Okay.
Okay, now you
Okay.
can see. Okay, questions will be there. 40% questions will be there from week 10 to 8.
Okay.
Yeah, but major portion will be from week 9 to 12.
Okay. Thank you. Right. I was wondering whether, because like whether I can take the chances or it should be kind of thing. So I will, if I focus on the 9 to 12, then 60% of the portion for sure is going to be.
Yes.
I'm not living it, but only thing is I could see that from 8 to 12, I need the thing. So I need to revise more. So I just want to clarify from my side whether is that I should put more effort on that part. Thank you so much.
Yeah, okay. Anything else?
And when we come for the revision part, so could you please tell, like, I think there is Professor Usha is going to take on tomorrow.
Yes.
Tomorrow from
Yeah,
6 to,
tomorrow is the revision session from week
and
9 to 12.
oh, that's going to be week 9 to 12, is it?
Yes.
Okay. And that will be the only revision.
Yeah, this is the only revision session.
Oh, we won't have anything later than this.
No, we will be having our enter mock discussion session only.
Yeah, that's on Thursday at 6 to 8. Okay.
That's on 10th. We will
Yeah.
send a announcement for that also. We have scheduled it. We have to send a announcement for that. It will be on 10th of April.
Okay.
Yes.
Okay. So these are the major two revision sessions that we have.
Yes.
And both these, I mean, whether it's, the session tomorrow and on Thursday, both will be recorded. We will be able to access later on YouTube also.
They will be recorded.
Because the interim mock discussion that you said, they don't provided any link in the YouTube link as of now for the Thursday session.
Okay, I'll check it. After the session, it will be available.
Okay. That's it.
Yeah.
Great.
Yeah, okay, thanks.
Thank you. Thank you so much. Thank you.
Yeah, best of luck for your exams.
Thank you so much. Thanks a lot.